This is SciByte, episode 96, for June 3rd, 2013. Hi, everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast, live on a Monday, fresh on Wednesdays over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our always excellent Heather host Heather, something like that. Hey there, Heather.
Hey there, Chris.
I was going to say Heather the host, but then I realized I don't ever call you that. I don't ever call you that. So what are we going to talk about today, Heather?
Today on Happy Science, we're going to take a look at Woolly Mammoth blood, University Rover Challenge, conductive paint, crowdsourcing a telescope, frozen moss, viewer feedback, spacecraft updates, curiosity news, and as always, take a peek back in history and up in the sky this week.
Wait a minute. Happy science to you, Heather. Happy science. And that's too much show for a Monday. That is way too much show. We better kick things off to get it right. Let's do the news. All right, I don't know if we can do it. I don't know. It seems like too much show, but where do we begin?
All right. Woolly mammoth blood. Yeah, I said it. Like, for reals.
Gross.
Yeah, okay, so this might be a little gross for people, but it is too amazing.
Only in Russia.
Yes. So Russian scientists earlier this month actually uncovered a really incredibly well-preserved carcass of a female woolly mammoth on some really remote island. Now, they think, okay, the creature died like 10 to 15,000 years ago, was probably around 60 years old, female, makes it the oldest female they've ever discovered. But what was incredibly crazy is that they're claiming that the body, how well it was preserved. Like the lower part of it ended up in a pool of water that was just like frozen. And so the upper part of the body, kind of been in the tundra, it's got beat up. But the lower part was so well preserved that they were sitting there and they were picking at it, and they broke the ice beneath the stomach, and blood poured out.
Flowing blood, huh?
Yes, it actually flowed out. The muscle tissue was said to be like the red color of, fresh meat.
And it's actually still the shape. I mean, like when in this picture here they have of it, you can kind of see the outline of it at least.
Yes. Now, yeah, they'll still keep their shape quite a bit, but it was so crazy and interesting because the temperature at the time was 7 to 10 degrees below 0 Celsius. That's only 19 to 14 degrees Fahrenheit. So below freezing. So obviously, since it's flowing liquid, they're assuming that the blood of woolly mammoths probably had some cryoprotective properties, which would make actually a lot of sense that their blood would be completely happy in frozen temperatures.
So they have like a super blood. They have like Mr. Freeze blood.
Yeah, kind of.
Okay.
We'll go with that. And so if it all is true, like this is one of those times where something is so awesome, I keep my skeptical pants like on standby.
You think it could be a prank?
I doubt it because there are lots of pictures. There's a tube of vial that you can see one of the scientists holding up. And, there's a little bit of blood in the bottom. But it's just one of those times where something is so crazily amazing that they actually found, like blood.
Well, it seemed like if it's potentially that defrosted, then isn't it possible there could be bacteria living in there that's kind of screwed stuff up?
It's certainly possible, but in those kind of cold conditions, in kind of that, sealed location, less likely other than any cold or whatever this poor elderly female woolly mammoth had back in the day.
It really is something to think how there's just, even today, there's still these snapshots of time that are buried around our world that we're still discovering them, and who knows what else we're going to come across. And I would be really curious to find out if they get an analysis from this blood. Now, the question is, because this is, in my opinion, because this is coming out of Russia, this might be the last we ever hear of it. You know what I mean? Like they might just decide, okay, we got the attention. Now we're just going to keep everything to ourselves.
They say they're bringing in specialists from South Korea, from Russia, from the U.S.
Oh, good.
And so they're saying that all of these people are going to come together and study it. Of course, right now it is in a completely undisclosed location somewhere in northern Russia. they kind of spread their hands over the map and go like, "We're somewhere here,"
Hmm.
because you really don't want people hunting this down. I mean, scientists have already deciphered a lot of the genetic code of the woolly mammoth from like balls of mammoth hair found frozen in the Siberian permafrost.
Yeah.
But this actually gives a really good chance of finding some live cells, which could help if they want to try cloning
Hmm.
a mammoth.
Hmm.
So researchers signed a deal last year with the cloning pioneer from South Korea, who actually back in '05 created, the world's first cloned dog. So they're looking at it like, can we clone a woolly mammoth? I mean, they've gone through and scientists have said, okay, what is the largest elephant we have today that could possibly, you know, carry a woolly mammoth baby to term? And there's even like they're talking like a concept of an X Prize, like the one they had that X Prize get the for the you deliver stuff to the station. SpaceX and Virgin Galactic, those people were doing that. They're talking about maybe a Jurassic Park prize.
You're
Put my
kidding.
fingers quotes in air.
You're kidding.
Where
You're joking.
No. There's this like talk about this kind of X Prize type of thing where if you actually succeed in bringing back an extinct animal.
That's too funny. Seems like shouldn't we've learned our lesson from Hollywood on this one, Heather?
Yeah, well.
It's too tempting to study, isn't it? I mean, it really is. Yeah. Wow, they really are calling it a Jurassic Park prize.
Yes,
that's
they
not
really
a joke.
do.
Wow.
No, it's not a joke. It's it's one of those times where the name is so symbolic. It's just like a stamp, and everyone would know exactly. It's like, oh, that would be the kind of thing that would be.
I would like to actually go to a Jurassic Park. I'm not gonna lie. I would if they actually
would not.
Really. I mean, I'm not gonna hang out there, especially if it starts to rain and it hasn't actually officially opened yet.
Yeah, and the power might go out.
Right. I'm not gonna hang out then. But if it's been open for a few months, I might check it out. I might. Wow, that's a great one. Any other thoughts on that one?
No, it's just really strange, and I really look forward to see when we next hear anything about this.
All right, well, keep us informed. All right, Heather. I wanted to take just a moment here. Now, last week you had an awesome Star Wars book pick. This week, it's not a Star Wars book, and I'm going to warn you guys up front. This one is very technobabble heavy, so that's why I got it, okay? If you're not a huge fan of the technobabble, just like blah, 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 basically, here, I'll give you an example. They go into great lengths in this book that I'm about to pick on how the starships communicate between each other when they're at light speed and about to go into combat. I find that to be fascinating, and that's why I got it. Here, I'll play a little sample for you, just so you get a little sense.
CIC TCUSNA CVS America, outbound Ada Boota System, 20-25 hours TFT. The Spirit of Confederation reports she is taking very heavy fire, Admiral, Hughes told him. Damage to aft shields, damage to primary broadside weapons, damage to 2 of the 3 HAB modules. Fire control is down. Koenig was watching the Confederation's struggle on a secondary tactical display, which was relaying the camera view from a battle drone pacing the retreating ships. Straight-edged patches of blackness kept popping on and off along the battleship's length.
So that's the audiobook version, and if you are an Amazon member, then it is a credit. And if you are not an Amazon member and you use the link in the show notes, you will get the book for free. And even if you cancel your membership, you get to keep it. It'll also we'll have a link to the Amazon book, which is like $8 or $7, $7.19 for the paper version on Amazon, and $6 for the Kindle version. You got a good sense of how kind of techno-babbly it is just in that clip that I played there. But I kind of love that, and they introduce a lot of really interesting like practical concepts that you don't quite get if you follow the Star Wars and Star Trek universes very heavily. So it's new ideas, very fun. I've enjoyed it quite a bit, and it also supports syncing with the book version. Since the book version is only $6 if you get it on the Kindle, it's kind of cool that you can sync that with the audiobook version. So that's my recommendation. It's called Earthstrike Star Carrier, Book 1. It's a 5-book series, and I have a link to it in the show notes. And if you grab the audio version, it's 12 hours and 21 minutes, and they have it in that enhanced audio that's CD quality. And it's got outrageously good ratings, both on Audible, and it's got a great rating on Amazon as well. So that is my pick this week, Earthstrike Star Carrier, book number 1. And I'm planning I'm planning to go through all 5 books. And so far,
Wow.
I guess what I've been told is it really sets up all the technical world and how all the laws in the universe work in the first few books, and then you really dive into like character stuff in the following books. So I'm looking forward to it. All right, Heather, with that filed, let's move on to the news bite, which is not coming. No, that's the wrong one.
No?
I
Where's
am
the
gonna.
band?
Well, it's Monday.
Oh.
Yeah, so I have some other. It's Dylan. Sorry, Dylan. Okay, Dylan, do this one. There we go.
Oh.
News bite. Attaboy. That's my boy. That's my boy. I'm
Yeah.
teaching him. All right, Heather, what's in the news bite?
Alrighty. The University Rover Challenge. This is a competition hosted by the Mars Society. We talked about them a couple weeks ago, doing their little simulation up in the frozen Arctics. And what this is, it's a competition located in their desert research station in Utah. And so it's really rocky, barren landscape. Kind of looks Mars-ish.
It does, actually, yeah.
It does. If you like tinted the sky pink.
Yeah, you could put it through a filter, and you could actually totally believe it was a Mars location. This is great. Except for the guys who are just standing there breathing.
Well, and the cars and trucks in the background.
Yeah,
But
yeah.
what it is all these universities, they're allowed to spend up to $15,000 to make a rover, which can weigh no more than 50 kilograms or 110 pounds. And so what they have to do is it's got to be what they call a telerobot, which means you don't pre-program it. They have to be able to drive it without seeing what's going on. So they're like inside the habitat or behind a wall or in a truck somewhere where they can only see what the camera is showing back to them.
Okay.
So then they have a list of tasks that change every year. This year they had to be able to cross a very specific terrain. They had to follow a specific track, go through a number of be able to locate different, quote unquote astronauts, which are some of the staff people. They'd stand at various locations and they would have to go take their rover and find them, sort of deliver a package, as it were, like it was emergency supplies.
Okay, cool.
Be able to fix a dust-colored solar panel without using water, navigate an obstacle course, getting over boulders, passing in between PVC pipe gates. It's all these things kind of meant to sort of test all these different, can you do this, can you do that, can you do that, all things that would need to be used on Mars, really.
Yeah, right.
So the idea is, okay, so what if the astronauts were in the habitat on Mars and they're just driving their little rover around?
Yeah.
Remotely.
Yeah.
So this is the kind of thing that they're doing. And this year they had universities from Canada, from India, from Poland, from the US. And two of those teams had come back and had won a couple of times. And this year, the top 2 teams are actually from Poland. First place, practically perfect score came from Białystok University of Technology, and they're going Wrocław. Okay, I'm really sorry anybody who speaks Polish or is from Poland because I terribly butcher.
You butcher with love in the name of science.
I do total love. There's some clips in the show notes about these things. It's kind of cool. You go through and watch them, and some of the teams from Poland and overseas had to really spend a lot of time making sure they had raised the amount of money they needed to be able to bring it here, to bring the team here. Some of the teams weren't able to test until they were in the field because a manufacturer said, yes, we can get you there. And then it came time to be delivery and they're like, yeah, we mentioned 4 weeks. So it's like they get the last of the materials for the rover like a week before they have to travel out there.
Oh, so they don't get a chance to try it all out.
Yeah, but it really mimics real life. Something might happen in such a way.
I suppose so.
That,
challenges happen, right?
Challenges happen. You have to work under a budget. You have to work where goodness only knows what's going to happen out there. Will it tip over? Different things. So all these universities get a chance to kind of come out, and then they get to strut their stuff and wear their awesome, cool rover badge for a year. It's just really interesting that they can do this sort of thing and to see all the different kinds of designs that are come up with.
Very good. Very good, Heather. All right. Well, everybody can go check out the links to that in the show notes, including a few YouTube videos of the rovers in action that people got and uploaded to YouTube, which is pretty cool. Pretty cool to see that. Gosh, we live in the future now. People are just building robots. All right, Heather. Why don't we move on to the 2-Byte News. Nope, the 2-Byte News. Gosh, come on. On a Monday night, it's the 2-Byte News. I pay him in lollipops. You can only expect so much.
Oh, don't blame him. It's the band. They're caught a day off.
They're gonna show up on Tuesday either way. I have to pay them. No,
I'm
paying them. Yeah. Oh yeah. No, it's part of the contract. It's horrible.
Okay. That's why they're kind of sleeping it off today.
All right. So what are we gonna talk about in the 2-Byte News?
All right. Some conductive paint. This substance actually allows you to sort of paint liquid wiring on any surface except for skin.
I love this.
Yeah, like Radio Shack stocks these paint pens where, the inventors say, yes, it's totally non-toxic, electrically conductive, dries at room temperature. So this specific type, they're saying, hey, it can be great used by hobbyists, by artists, by engineers. In addition, because it's non-toxic, you could actually use it for educational projects, toys, touch-sensitive paper,
Wow.
all these kind of things.
Wow, that is so cool. Yeah, she has an example here in a video that Heather has linked in the show notes where they actually have like the battery taped to a piece of paper, and then they're using the paint to lead from the battery to a circuit.
Yeah.
Pretty
And
amazing.
she painted a giant controller on a piece of paper. Had the wiring and then
played Pac-Man.
played Pac-Man with it.
All right, that's pretty neat. Okay,
Yeah,
I'm impressed by this.
Yeah, I mean, it could be signaling, it can be powering. You could use it as, potentiometer, interfering microcontrollers, or, you could power a device like an LED or some small speakers or something. So it's one of those things where you touch and you could actually start, a card or something making sound. So it's pretty, I looked at it, it was really cool. I know that this kind of stuff has happened before, but it was just that it kind of piqued my interest this time around, and the fact that these people are very adamant that it's, non-toxic and dries at room temperature, and so it's like, I could use that.
It's even more accessible than ever.
Yeah.
That's awesome. All right, well, while we're on the keeping things accessible track, why don't we talk a little bit about crowdsourced telescopes? Now that makes a telescope sound accessible to me.
Yes. So what this is a Planetary Resources. It's a private venture. It's like aiming to mine near-Earth space rocks. And it announced on the 29th of May that it is actually going to build and launch a space telescope for, quote, public use. And they're raising the money for it on Kickstarter.
Oh, look at this. Another Kickstarter project, huh?
Yeah, they're aiming for $1 million. They hit 200,000 on the first day.
Wow.
As of this morning, filming it June the 3rd, they had reached $714,000. So they're getting pretty closer. It's going to be 2 telescopes. It's going to be like a twin to their spacecraft that they're developing to actually track and study asteroids in preparation for a mining mission.
Okay.
So this is they'll have a trial version, then they'll have this version, and then they'll have they're completely dedicated to them. So it just like in Kickstarter things, the set that you donate to, you get different things. So
I love that they have a space selfie. Take a selfie in space. That's one of the
Yes. It's what it is they have, it's not that big. It is only like 200 millimeters, a little over 7.5 inches long. This thing is tiny. The Hubble Space Telescope went up in the shuttle, and like in the space that it took in the bay, 1,000 of these could fit in it. So really tiny. What they do is they have like a little screen on the side of the telescope, and they have a little camera that pops out. So it's pointing at the telescope, and so you could see the telescope and the Earth behind it. And if you pay a certain amount of money, you can have your picture displayed on the screen, and it'll take a picture of the picture that you have displayed in space.
That's pretty fancy.
Yeah, it was hilarious. I mean, okay, so these guys are real nerds. So it is called the Arcid Telescope. Yes, and Star Wars fans, if you're like super Star Wars fans, it might sound slightly familiar.
It ringing a bell.
Because they were looking for like a code name for it when they were just starting, and somebody was a real Star Wars person, and Arrowhead Industries was the industry in Star Wars that manufactured droids and heavy weapons. It's the people that did the Viper probe droid. So when
Oh my
on
gosh.
Hoth, that circle floating probe that is trying to find Echo Base.
Yeah, yeah,
Yes,
yeah.
that the industry who made that is what it's named after, because they'd started off doing in the Star Wars universe doing probe droids to search for planets and asteroids for resources. So they kind
That
of
is nitty gritty. I got to be
yeah
honest.
they grabbed it from there. Like I said, these are super nerds, but
Them.
yep. I mean, it's gonna go. They'll have be able to take 150 of those quote selfies and 15 astronomical observations per day. So if you donate a certain more money, you can actually say, I want to donate this time to a school, or hey, I want to take a picture of this and go and find it and take a picture of that, and it's mine.
And they've got the celebrity star power of Brent Spiner to back him up.
Yep, and Bill Nye, Science Guy, and a number of people are all kind of rooting for this little guy. And
Bill.
they had a random facts sheet.
Oh yeah.
It's like 8 times faster than the SR-71 Blackbird, flying at Mach 3.
Ooh.
San Francisco to Boston in 10 minutes. But it was hilarious because they'll say they're downloading things at DSL speeds, so they only get a couple of minutes per orbit to actually download things.
Oh, okay.
And the first ground station will be in Seattle, Washington.
Oh, can I visit?
So if it ever gets up, of course that's like the caveat for the whole thing. It's like,
well, they're at $700,000 right now.
Well, yeah, but there's a lot of things between now and in space.
Yeah, oh, for sure, yeah. Getting funding is only one part of that puzzle.
Yeah, getting funding is one part. So it's all like starred. It's like, this is considering we actually get there. If we don't, sorry, thanks, love you hearts.
Yeah, $1 million actually seems a little low. I mean, for building something that's going to go into space.
Yeah, well, they're not going to launch their own rocket. They're going to piggyback off rockets, which a lot of these smaller ventures can do. So you piggyback off that. And then it's small. So it's not like you're grinding a giant mirror or anything.
They're actually based in Seattle, too, which is really cool. So I should go down there and do a science interview with them. Hello, we'd like to talk to you. Hello.
The most hilarious thing out of the whole thing that I read, even funnier than how they name it selfies, which is actually what they name it, was that they're like, it runs off 50 watts, the same as a standard household light, or 111 hamster wheels. They actually say that on the sheet. On
they are geeks, aren't they?
It was hilarious. I mean, so I kind of really want this to like work and go, because this is all like the private, private funded sourced things.
It's still, and for those, and think about it on a larger scale, for those of us who wish that the space programs in the United States would get more funding, this is sort of us voting with our dollar in a sense. I mean, it's very small scale, very beginnings of that, but it could lead to something that sort of says, all right, well, if the government won't fund it, the people will.
Yeah. So it's kind of cool. I'm looking forward to seeing where this goes, and the selfies are hilarious. I'm like, okay, what all crazy things are going to be taking pictures of?
The internet is making the entire world into a bunch of narcissists. But you know what?
Yeah.
I wouldn't mind doing that if I could. But I'm too busy focused on my moss. I have a big moss problem in my house, and I was thinking one way to finally get rid of that moss once and for all would be to freeze it. Then I'd never have to worry about it again, right?
Well, maybe ... question mark, not really.
Oh, dang it.
So they've actually recently found that even after hundreds of years buried under ice, mosses can actually start to grow again. They went to Canada's Ellesmere Island on the Teardrop Glacier. And so, it's been retreating since the last little ice age. But they found some exposed ground where some clumps of moss looked dead. But among these brown tangles of dead moss were a couple of green little sprigs. And they took that back to the lab. They used radiocarbon dating, said, all right, this moss was about 400 years ago. And based upon the movement of the glacier. It's probably been uncovered for less than 2 years. And so that all they had to do was grind some of the plant, the dead up, give it a little nutrients, water, light, let it just be. And 7 out of the 24 samples they took started growing moss again.
No
They
kidding.
started actually growing again. Now, budding plants like moss, they don't actually come from seeds or spores or anything.
Huh.
So any cell can be reset, which is why just like grinding it up and letting it go would able to do it. Now, how long they'll actually stay viable or what they can do, anyone's guess, but it kind of suggests that mosses might actually help. This kind of thing might actually help repopulate an ecosystem, get it restarted.
Oh, right. Yes.
Once these kind of, natural glacier movements go back and forth.
Sure.
So
Oh,
the
yeah.
fact that it came back to life was nuts. We're like bringing back ancient life all over the place this week.
Yeah, no kidding. And scientifically speaking, I think a yard full of moss is easier to maintain than a yard full of grass. Just putting that observation out there. Heather, I have a notification on the SciByte 2000. It's either the self-destruct or... Oh, good. It's a little incoming communications.
Just go ahead and push that button willy-nilly.
Hey, I figure 50-50.
Okay.
So what is our
So-
incoming communications?
This week is actually from my hubby.
Oh,
It was
direct
a
line.
direct line about an exoplanet that has been directly observed. There has been a newly discovered a giant gas planet that was actually directly photographed, only about 300 light years away from Earth. Now, generally, you say, okay, exoplanet, like Kepler, where you see the Kepler Space Telescope, where you were seeing dips in light in front of the star, which you were kind of inferring from a planet there. But there are only a couple of planets, and this is one of them now, that they observe it, block out the starlight, and look in the infrared and actually see the planet itself completely as a separate object.
Awesome.
Now, they just released it, and this circling a really young star, now is based on the brightness of the planet itself. They estimate it's only about 4 or 5 times more massive than Jupiter, which would make it pretty much the smallest planet that we have directly observed.
So that is ridiculous because Jupiter, as far as I knew, my scale of planets, Jupiter's a big boy.
Yeah, well, on the scale of exoplanets,
Okay.
there are quite a number of ones that are
Right.
ginormous.
Right.
But the fact that we're directly observing it, saying, okay, we have now spotted something 4 Jupiters big, 300 light years away.
Wow.
Not by seeing it pass in front of a star, but by actually looking at it in the infrared. Now, what's really cool is even more interesting is that the star is actually pretty young, only 10 to 17 million years old, which is really young in star years. But so it makes this exoplanet formation like it's fairly much earlier on than our solar system, most definitely. So it's kind of but it kind of lets the researchers get this potentially intriguing kind of snapshot view of this part of the solar system formation.
And again, unless I'm mistaken, another great example of finding this interesting bit of data in a whole mountain of data, right? They already had these pictures, and they went
think
back.
so.
Yeah, I was looking at the article. They don't make it quite clear, but I think these were existing pictures that then they went and knew, oh, we should look here, and they found it, which is always fascinating to me that we've done so much science that we just now have databases full of science that requires science sifting. That's just how.
Yes.
You gotta get your science sifter out. All right,
Yes.
well, good news. SciByte 2000 tells me we have a spacecraft update. Little lunar gravity map.
Yes. Quite a whiles back, we had the Grail Space Telescope, Ebb and Flow. That was the 2 little satellites that we had orbiting the moon, and they were synced up in a very, very precise fashion so that as they were orbiting, tiny, tiny amounts of getting closer or farther away was telling scientists about how the gravity of the moon was affecting it, because the gravity of the moon is not flat, it's not solid. It has a lot of dips and curves, and if you see the maps in the video or in the show notes, you can actually see it's like red and blue speckles, and that's not height, it's the strength of the gravity itself. So they're able to make these really, really precise measurements of the different how where the gravity was stronger and weaker. So we've kind of seen, and we've seen that kind of a thing, what they call mesons, gravitational anomalies. We saw that all the way back in the 60s as, NASA officials and others were planning the Apollo moon missions.
Mm-hmm.
They put things out and they're like, oh, it's not just a simple straightforward orbit. There's little things going on here or there that higher points of gravity, lower points of gravity. So they've been able to see, and they're like, okay, we can see giant craters in the moon, and you see those giant, flat plains where it's, lava kind of filled it in, and we expect, that's what happened. So they went and they looked at some big impact sites on the near side of the moon that faces us, and then the far side of the moon, kind of really looking at these. Now, on the near side of the moon, they saw these partially filled in with, ancient flows of really dense lava, which is like, okay, that accounts for the mass, this, positive gravitational anomaly. There's a whole bunch of mass there. There would obviously be a little bit more gravity there.
Yeah.
But in other locations where they were looking, the lava flow that would have filled it in would be too thin to exactly explain why there would be higher gravity there.
Oh, really? So what's that mean?
So it means that they were trying to figure out what was going on here. So now what they've gone through and looked at is, hey, something unexpected was here. What actually occurred? So what they're thinking is now that, so giant asteroid impacts, makes a really large crater on the moon. Now what happens is it doesn't like totally lavify. All the surrounding material kind of slumps in, collapses inward. Think you're baking some bread or, something that cooks on the outside. It's kind of still mush on the inside.
Chicken pot pie.
Not quite chicken pot pie, but we'll go with that. Something with a thinner crust.
Oh,
so you
okay.
drop a rock in there. Oh, sad. Now it's bad. But
yeah.
So not necessarily is it going to completely, go liquid around that area. But what might happen is that all the surrounding sort of slumps inward towards that hole. So you have this different type of thing that's going on. So it's the stuff, it was the ground around it that sort of slumped down, filled in that area. And the reason why you would have these sort of peaks in the middle would be because everything slumped down and hit the middle and kind of jammed up again. If that makes sense, because I'm waving my arms in the air in a way that would make sense. I really promise.
I find the gravity map to be pretty interesting. That they've really got just essentially every nook and cranny of that thing mapped now.
Yeah, so now they're really able to go through and say, all right, take the visual images that we have and take these gravity maps and really go through little section by section to kind of figure out exactly what happened in the formation of the moon. They're really getting to try to figure out what happened below the surface. What's happening deep in there? How's it formed? What happened in its history? So these kind of combination really gets us a better chance to make these sort of new observations and try to make new, so that we can really look at this stuff.
And make future plans for hopefully revisiting, I hope, or at least sending robots.
Well, something.
Well, while we're up and above the atmosphere, what do you say we head over to Mars and do a Curiosity update? You ready?
Let's go.
And liftoff of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
That is a wheel.
What? Are you?
That is a wheel.
Are you? Yeah, I was going along with the clip too. All right. So, what was Curiosity up to?
Alrighty, they have their Curiosity Radiation Assessment Detector. It talked about how they were going to make a big announcement about their radiation findings last week, and they have made it. So they were able to say they were taking the radiation readings all the way to Mars on cruise control. So they're able to kind of see, what kind of radiation exposure would human explorers would see between here and Mars. Now, as of right now, it looks like that amount would actually exceed NASA's current career limit for astronauts. So they have specific radiation, ways to measure radiation. And once you hit that limit, then you're out, you're retired. So looks like as of right now, it's kind of exceeding that amount.
Uh-oh.
But we'll kind of see what happens. It may just give them a better idea of what kind of shielding they need. Now, there's, two forms of radiation that's going to affect. There's galactic cosmic rays, which are things like from supernova explosions, other really high energy events from outside the solar system. Since they're so high energy, really hard to shield from them. Only so much we can do as of with the technology we have right now. The other kind of radiation that we can do stuff about is solar energetic particles. Those are from like solar flares or coronal mass ejections, all these kind of things from the sun. So we're able to see that the radiation detected, like accumulated like on the trip to Mars, would be about the same as if you had like a whole body CT scan every 5 or 6 days. So it's a little bit higher than we want right now. On one of the charts, you can see it's very steady, a couple of really big spikes where, a coronal mass ejection or something hit the spacecraft itself. Which as it was going, you could actually, they're actually happy to kind of see that happen because we can say, okay, what does this kind of event mean as far as the detector? So we say, okay, well, in general, the shielding needs to be able to protect against this much energy. Now, maybe you have a safe room that has a lot more protective power. It's just much smaller that, hey, there's a solar flare coming. Everybody in the safe room.
Everybody in the tank. Right. That's what I was thinking. I was wondering if they could, if science fiction tells me that you could have some sort of safe room at the center of the ship that's maybe more shielded than the outer stuff, as long as the equipment could take it.
Yeah. So they're kind of looking at this, and now they're going to look at long term what the radiation readings are on the surface in itself. So all these kind of things are giving them a better idea of, okay, well, what kind of shielding would we need to protect the astronauts on the way there? What kind of shielding would we need on the surface of Mars? So getting all these things together, and it's one of those times where they're kind of interested in seeing one of those coronal mass ejections actually hit Mars sometime during this time. So they can see what happens on the surface. When it hits the Earth, that's, we see all those really gorgeous aurora. And that is all these particles being driven and directed by our, magnetic poles. And they have, we're protected by the Van Allen belts and such. But Mars has more, it doesn't have a large protective shell like that. It has very small, localized sections of magnetic, readings that'll protect it from the surface.
Sure.
So they're kind of interested to say, okay, how much gets through, how much gets to the surface, and what would we need to guard against?
Well, and then once they get all those pieces put together, then they can start selling cruise liners to Mars trips, and then I'll sign up for one of those, and I assume it's all safe. That's what I'm waiting for.
Okay.
All right. Now, I got a little bad news for you. The time machine's in the shop because it is Monday. However, I got the old one, so the door is just a little loose. Just kind of turn the handle when you get in as you close it, okay? All right.
Okay.
Here we go.
Okay.
Oh, sorry, no seatbelts either.
No, wait.
I sold those.
Doing?
Oh, here we go. It's a little bumpy. Sorry, Heather. Oh.
What are you doing?
Oh, all right, there we go. See, that wasn't so bad. I'm not sure.
I really had my arm extended out,
Sorry about that.
Ripped.
One arm's going to be about 135 years older than the other arm. I couldn't help it, Heather. But that does take us to our destination this week. 135 years ago, June 6, 1878. What happened this week in science, Heather?
Liquid air was actually obtained at a temperature of minus 192 degrees C. So this professor, James Dewar, in the Royal Institute in London, and I really know how to say his name.
He's a real doer.
No, because so what he's able to do is, try sidetracking myself, is he was do a small scale production of liquid air. He's able to cool it to such a degree that he actually could liquidize it. And he actually, showed an audience, and it remained there for a couple of times. He, had it in a vacuum jacket. So what now is they have, gas tanks that you may have seen here or there on television or in my lab. And then there are these giant silver cylinders trying to hold my arms out to see about how big it would be. Like, I'm not that big, but I could definitely use it as an escape pod and have, a little room to move and stretch. And so These are have vacuum sealed walls, and inside you can have really, really cold, like cryogenic temperature, liquid nitrogen, or all these kind of things. And so I was like, oh my gosh, that's where they came from. It was James Dewar. That's where they got their name.
Wow, that's very cool. And now think of all the fun things we get to do with cryogenics and liquid air. Thanks, Mr. Dewar. I guess that was Dewar with a D-E-W-A-R. So Dewar.
Yes.
Maybe he might have been Dewar. You never know. All right,
Yeah.
Heather. Well, I'm going to recalibrate the SciByte 2000 so we can look up into the sky this week.
Yes. On Friday, June the 7th, about 45 minutes after sunset, you're going to see Mercury and Venus to the west to northwest, about 5 degrees or 3 finger widths apart from each other. That's 3 winger fifths.
Winger with fists.
Yeah, say that 3 times fast. Say that 1 time slow. Held at arm's length. So, and then you'll see those 2. And then to the left, upper left of them, by quite a little bit, you'll see 2 brighter stars. They're Castor and Pollux, about the same distance apart from each other. And those are the 2 heads of the constellation Gemini, the 2 twins. And on Saturday, June the 8th, just after dark, if you look to the southeast, you're going to see an orange-red star over there. That, unfortunately, isn't Mars.
Ugh.
It is the red supergiant star Antares.
Okay.
In general, this week, we're going to see Saturn in the south during the evenings. And Mercury, Venus, and Jupiter are still putting on a show. And the afterglow of sunset, you're going to be able to see them making kind of a straight line pointing towards the west to northwest horizon. Mercury is going to be the highest one up. Venus is the brightest one in the middle. And Jupiter is getting closer to the horizon, getting progressively harder to see as the week goes on. But they're still putting on a nice show over there in the west to northwest.
Very good. And don't forget, if you remember you see something in the sky, but you can't quite remember what it was, Heather said she even has a visual guide in the show notes. Just go to jupiterbroadcasting.com, look for SciByte 96, and scroll down towards the bottom of those show notes, and she has all of this listed out as well as the visual guide. Heather, I think that brings us to the end of this show, doesn't it?
I think so.
Well, that was a fun ride. We got through it all. I didn't think it'd be possible on a Monday evening, but we managed to do it. Wow, look at us. Well, there you go, everyone. Now, Tuesdays are normally the nights we're live, but you can always check jupiterbroadcasting.com/calendar to get the latest schedule. Whenever there's adjustments, they're always updated there. Heather, thanks for the great show.
Thank you.
And thank you, everyone, for tuning into this week's episode of SciByte. We'll see you right back here next week.